Hello and welcome. There we go. Hey, how are you doing, Tilla?
Hey Ryan. Yeah, I'm doing good. How about you?
Doing great, thank you. We are streaming today about data retention, TimescaleDB.
That's right. Um, so I suppose the sound is good. I hear you well, Ryan.
That's great.
Okay. All
So,
right. So yeah.
yeah, we have a number of things that we are trying to do better at streaming about. Particularly these key features in TimescaleDB that really can impact how you're using your data. We talk about billions and billions of rows of data. I think just 2 weeks ago you did a stream on continuous aggregates, right?
Yeah.
Yeah. So continuous aggregates is one of them that plays into data retention at some level, which I know you're going to talk about a little bit. And also, just in general, maintaining, when we're talking about this barrage of data that we're getting from all kinds of devices, is this really a key feature that doesn't exist in quite this way in many other time series databases? There's ways to think about data retention. There are ways to TTL data out at some level, but how it's done, the impact on the size of your database, things like that, really can become key to managing stuff well. So I'm excited to hear what you got to say today.
Yeah. So let me start. As Ryan said, we are going to talk about data retention. Let me quickly show a quick agenda for today. So basically, first, I'm just going to cover the basics of data retention from a context of time series data sets. Then I'm going to talk a little bit about why data retention is useful for specifically for time series data. How does data retention work in TimescaleDB? We are going to do a short demo where I will show you how to set up data retention policies. And also, I'm going to show you what's the performance difference between basically using data retention uh, the TimescaleDB way, so to speak, versus using just delete statements to delete all their data. And then at the end, I will also show a brand new feature that we recently launched, which is the 16 gigabyte disks in Timescale Cloud. So that way, if data retention is something that you want to uh, not do you maybe because you want to analyze all their data as well. Now there is a very easy way to store a lot of data, 200 plus terabytes of data inside Timescale Cloud. So I'm going to cover
Yeah,
it on that as well.
that's awesome.
Alrighty. So first, what is data retention? So basically, data retention is the process to delete all data and keep only fresh data in your database. Now, fresh could mean a lot of things. It depends what you consider fresh or what your database requirements are. Maybe for some use cases, when you only analyze data from the past couple of weeks, you don't need uh, data that is older than a couple of weeks. But in some other cases, if you want to analyze, the whole last year worth of stock data or sales data or whatever kind of data you have, then obviously you have a different meaning of fresh data. And then basically with data retention, you periodically remove data from the disk, hence saving disk space. And you do this because you find older data unnecessary because it's too old. But it's also important that once you delete data, it's gone. Like you won't be able to analyze it further, and And so this is something to consider as well. Maybe you just want to downscale with using continuous aggregates. So that way you still have some kind of aggregated data from your older data sets, but you can still save disk space wise.
Right. So data retention really depends on the use case, right? If you are doing, we have a lot of people that do monitoring, like with PromScale and others, Prometheus and so forth. And so you have such high rates of data. For a lot of people, it's just about data retention. I care about stuff for today, maybe this week. I need to know how my network was working. I don't really care that much about what happened a month ago. Maybe I need a down sample just to know what the highs and lows of some network traffic was. So it really is, it's not about retaining lots of data. It's just about, I just need an efficient way to just keep the current stuff current and get rid of the old stuff. But then other people, as you just said, it really can be helpful to know that I can keep lots of current raw data, maybe months worth. But at some point, it really is good enough for analysis in the future to just have, hourly or daily aggregates and highs and lows and some other stuff. And so we can, you can retain lots of the data just in a new and different form.
Exactly. So moving on, we already touched upon this topic, but why is data retention useful, specific for time series data? So with time series data, it's interesting, like as Uriah mentioned, usually, again, it depends on the use case, I suppose. Most of the time depends on the use case, but maybe we can say that usually time series data is more useful if it's recent, and as the time goes and the data is getting older, it becomes not less valuable, but maybe you don't use it as much, or maybe you are more focused on data that is more recent. Would that be fair to say, in your opinion?
Yeah, I totally agree. I think that's a really good way to talk about it.
Yeah, and so the older data, the less value it might have.
Right.
Now, a question that might come up: can Postgres already do something like this, or data retention? And no, currently there is no built-in Postgres way to set up like data retention policies. Yeah, did you want to say something?
No, you're good.
No.
I love this last point. We get this so often from the community, right? Why doesn't this work well?
Yeah, why can't you just use delete? Or if you use the delete statement, why is it slow? Because basically without TimescaleDB, that's what you sort of end up using, which is just a delete statement, and you filter based on an interval, and basically just delete these rows one by one individually. And the problem with it is that this can be slow. And why is it slow? Brian, do you want to explain it? Maybe you are.
Yeah. So, one of the reasons we've gotten this question a lot, specifically in community, and this is what most people are used to, right? You have your main statements in SQL. You have insert, you have update, and you have delete. When you get such massive data, the way that Postgres works, there's an implementation that we use called MVCC. A lot of databases use it. And it's a way of saying, we know that there are going to, as you insert and update data, there are going to be multiple versions of data of a row at any one time. That's a transactional in nature. You can be reading the current version of a row while I'm updating it behind the scenes at the exact same time, but we have to have consistency. And so there's multiple versions. When you delete, two things happen, at least two things. One is we have to mark individually, essentially, every one of those rows as marked for deletion, right? There's going to be a process later with vacuum that's going to free up that space. And so you have to take a lock. Postgres says, well, I need to make sure someone isn't updating that row before I delete it. And so there's a lock issue that happens there. Sometimes you can try and delete something. In a really heavily used database, you might not even be able to do a delete, right? Because you can't get the lock you need on the partition or in the table. But the other big reason is also just the growth of the database. Anytime you do lots of data modifications, that data is not actually deleted at that moment. And so you have to wait for, Postgres has a process called vacuuming. Other databases do it differently. But you have to, at some point, Postgres will come around behind the scenes to actually free up that space. So it doesn't get freed up immediately. And then the third thing that can happen is, because this is a logged database, right? This is a transactional database. The process of deleting rows is logged. And so now your log, what we call the wall, the write-ahead log, that has to be written to in case something happens in the midst of this transaction. And so now your database is going to grow because we have to log that stuff is happening in case we need to roll it back and some other things. And so it's just not an efficient way to delete lots of data, particularly if you're doing weeks or millions and millions of rows at a time. Sometimes it might not work, right? Just because you got to wait for that lock, and it's just really hard.
Yeah. So
does that make sense?
Yeah, absolutely. So basically, we could just say that the delete statement is just really not an efficient way to get rid of like a lot of old data.
Correct. Yep.
Now let's see what is the TimescaleDB way and how it works inside TimescaleDB. So basically, in TimescaleDB, you can set up data retention policies, or you can manually drop chunks. If you set up a data retention policy, what that will do is that it will regularly check that data based on the provided interval. Let's say you want to delete data that is older than 2 months. Then and you set up a data retention policy with this interval. Then TimescaleDB will look at your database, and it will delete the chunks that are older than 2 months. So basically, it won't delete records one by one. It will drop chunks, and this way it's much faster. And you can do this in an automatic way by setting up policies, or you can manually drop chunks. This is a one-time job. And again, you define the interval. You define something like you want to delete data that is older than 2 weeks or 6 months or 2 years. And then whole chunks will be dropped. Now, in either case, if a chunk is going to get dropped, so not individual records, it will be only dropped if the record doesn't contain row from the given interval. So basically, if no records exist in the chunk that is newer, then it can be dropped. Does that make sense, Brian?
Yeah, right. So this is, in fact, just this week, someone was asking about this in community Slack. The thing, as Attila is saying, thing that makes this unique is that it's about the way that we chunk or partition the hypertable under the covers. And so the retention policy is always looking at the boundaries of the chunk, right? And so there can't be any newer data. That's what I love about this last statement. Because we we know the data that's inside of a chunk. It has what we call a range start and a range end. We're always looking at that range end date for the chunk. And so what the retention policy is actually saying is, don't go find me rows, that are older than this. It's go find me chunks whose range end is older than the interval you've specified. Like you said, if it's always based on now. So when the retention policy runs, whatever point in time that is, we say now minus whatever your interval, as you said, maybe 2 months. So we say, okay, what is that date time? What's that timestamp? And go look for chunks that have a range end older than that timestamp. And if we find any, now we can go ahead and drop them. So it's the whole thing at once. Again, it's essentially dropping a table. It's a subtable, it's a chunk, not deleting individual rows. So it's super quick and it just hopefully much easier to think about, right? It's just, you get the whole chunk done and you move on.
And also, I think something that comes up sometimes in the Slack community is that the user defines this interval, and then they can still find individual rows that are newer than the defined interval, and they don't understand first why that is. But the reason is that that specific chunk had data, it had data that is newer than the interval, and it probably also had data that is older than the specified interval. And so TimescaleDB didn't drop that chunk because it had newer data.
Right. Yeah, this is where chunk time interval becomes really essential, right? And it's something we talk about a lot. In fact, probably something else we should do a stream on. You know, picking that chunk time interval, when you create a hypertable, you get, by default, it's 7 days, right? So that means every 7 days worth of data, not literal 7 days. It's, you know, if I create a hypertable and I immediately insert 3 months of data, I'm going to get, you know, 3 times rounded up to four chunks per month. If it's 7 days, let's just assume I'm going to end up with 12 or so chunks. And you can change that period depending on your data size. And so you're right. Oftentimes we forget, you know, I see a lot of people, particularly in the crypto and financial space, who are getting fast data in, and they want to have a really small instance size. They don't want to pay for a lot of disk. And I totally get that. So they think, well, I create a hypertable, I insert data, millions of rows a day, and I'm going to drop it after 24 hours. And like, but the data's not dropping. Why is it not dropping? Well, because your chunk size is 7 days, and we're not going to drop the chunk until 7 days have passed, because the range, the boundaries of that chunk is a 7-day period. Now, the opposite of that is then people say, okay, well, I'm going to make chunks that are 5 minutes. Like, well, that has other implications, right? You're not going to get good compression. You're going to end up with a lot more chunks, which will affect planning time and query execution. So there's a nuance, but absolutely knowing that specifically this is about the range of that chunk, and whatever you set up as a chunk time interval really impacts how this works.
Right. Okay, now let's see how to set up data retention policy. So basically, it's very simple. So you use the add retention policy function. Then as a first parameter, you define the name of the table. And then you specify the interval, which in this example is 24 hours. Now, one important thing is that one hypertable can only have one retention policy. So, for example, if you want to change a retention policy, you need to first drop or remove the previous data retention policy, which you can do with the remove retention policy function. And this will drop the retention policy. Now, if you add the retention policy, you can see when it will run next, and when it ran in the past using the one of the TimescaleDB information views. In this case, it's job stats, which has this info, and this view contains all the jobs that are running in the background controlled by TimescaleDB. And then if you want to manually drop chunks, you need to use the drop chunks function, and same parameters as with add retention policy, the name of the table, and then the interval.
Yeah, the two things to note here. So I love that what this illustrates is that setting up a retention policy is really can be, if you really know what you want, it really can be a set it and forget it kind of operation, right? We have an engine that's running in the background. It will run every, I think in this case, I think retention policies generally run once per the interval by default. You can change that, but so in this case, it would run once a day to see if there's anything older than 24 hours that it can drop. But it's really set it and forget it, but you can see what's going on. And then the other thing here, and if we look at the documentation, is the nice thing about drop chunks is that you can actually specify, there's a couple other parameters. So by default, you have interval 10 hours. That means any chunks whose range end is older than your interval, it's just by default. You can actually go forward. So there have been instances where people maybe get data that's ahead of time. And so there is actually a newer than option. So you can manually, you can't do that through retention policy by default, but you can actually drop chunks where the range end is newer than something. So maybe for whatever your use case, you need to keep, older data on a table for some reason. You're going to reduce something. Maybe you did an import and something about the newer data went wrong and you need to redo it. Rather than delete from greater, where time is greater than, you can just say, hey, delete the chunks that are newer than X, and I'm going to redo that data import.
Right. Now let's do the demonstration part. So let me switch over to dbWA. Oops, spoiler. So I'm using dbWA to basically connect to a TimescaleDB instance. Let me increase the font size a little bit so easier to see. So basically, I want to show, well, a couple of things. But first, maybe let's see the data set that I'm using as an example. But it could be, any kind of data set or database you are working with. I'm using a stock database, which includes data from the past, I think, about 10 months, intraday stock prices for a lot of symbols. And these are minute level data records. So for each symbol, we have one record per minute. Here's a small sample of the data set. So first, let's see how to drop chunks manually, and how you can actually check the amount of data that has been dropped. So first, maybe let's see the period of this database. So the very first time where we have records into the database, and the last time. So if I run this query, we see that we have data between 21st of December 2020 and the 1st of October 2021. And now let's see how many rows. Oh, and by the way, I didn't mention that I have a lot of tables. Well, not a lot, a few tables on the left here. The main table is stocks intraday. We will be careful not to touch that because that's the original table. The other tables are just duplications, but they include the same data records.
Yeah. So this morning we met. I don't know. Maybe you're going to say this later, but I feel like this is a good point to say this. Right? We were talking about this as we were preparing this morning. It's like the power of drop chunks is almost like, it's almost instant. And so if you don't think about your data retention policy correctly, or you're like, oh, I wonder what drop chunks does, and you execute this and the chunks are gone. If you don't have a good backup, I mean, this really is doing data retention. It's really removing your data. It's not just going to magically come back for you if you didn't mean to do this, right? So again, drop chunks is essentially a non-logged operation, right? It's not the delete, which you potentially could roll back if it's in a transaction. You have to have a backup to get this table back, this data back. So it's a good reminder, and that's why you created all these duplicates so you could play with it, right?
Yeah, you need to have backup, and you need to be careful what table names you put where. And because soon, like if you're not careful and you just, because as you mentioned, it's fast. Like with dropping chunks, we will see that it's fast and it's gone. Like millions of data records could be done in literally 1 second. So,
yep.
All right, so let's see how many records we're working with. For the first demonstration, I'm using the stocks duplication 1. So if we run this query, we see that we have a little bit less than 10 million records, almost 10 million. And we can also see a chunk summary using the chunks detailed size function. And so if I run this, I'm basically just summing the total bytes of each chunk from the table, which is stocks duplication 1. And that's chunk size. And then I also count the number of chunks in the hyper table, which is chunks count. So basically, what we see here is that we have the total chunk size is 752 megabytes, and we have 42 chunks. So as we've seen previously, about 10 million records and 42 chunks. This is before dropping chunks. Now let's manually drop chunks using the mentioned drop chunks function. In this example, we are going to drop data that is older than 4 months. So if I run this, the returned column shows the deleted chunks. And as you can see, there are a lot of them. And basically, what we could also check now is the chunk summary to see what's left in the database. So if I run this chunk summary query again, what we see here is that the chunk size is much smaller. We now have 343 megabytes. And we have much less chunks, so we only have 18 chunks left.
Yeah, you just got rid of the GameStop era, man. All the GameStop data
that's
gone.
true.
Wasn't that end of December or something?
Actually, I think that was in like January. So that's gone. We won't be able to analyze that now.
Oh no.
Now let's
go. And again, I just want to reiterate, you've said this a few times, but that interval 4 month, that's always, by default, when you just do it like that without the named parameter, that's whenever you run drop chunks, it's from now. So it's essentially saying that the Postgres function now, parentheses, right, gives you the current timestamp minus an interval of 4 months in this case. And so whatever today's exact date timestamp is right now, go back 4 months. And now we're going to find any chunks whose range end is further back than that, and that's what we're going to drop. So
yeah, it always means older than 4 months. Now let's use a retention policy. Let's see how to set up a data retention policy on another table. But just to check, this other table has literally the same data. So if we quickly run this query, the time period of the data set is the same. Approximate row count is, again, almost 10 million. Now, let's see if we add a retention policy to this table, stocks duplication 2. Now I defined a 3 months interval. So basically delete everything, delete data that is older than 3 months, and do it regularly. So if I run this query, what we get back is basically an ID, which shows that the data retention policy has been added. Now, if we want to check if we want to know more info about this policy, then we can use the mentioned job stats information, TimescaleDB information view, and we can specify that only show those job stats that are associated with stocks duplication 2 hypertable, with which we added the data retention policy to. So if I run this query, we see that we are looking at information about stocks duplication 2. The job ID is the same job ID that we saw previously for the data retention policy. We also see when it was last run. So basically when the policy has been added, last successful finish, and some other data fields. Now, if you want to know more about this specific job, you can also grab the job ID and use this job ID to query the jobs TimescaleDB information view. So if I just paste the job ID here, then we can see detailed information about that specific job. And here you can see that it's a data retention policy, and you can also see some other configuration of the this specific job. And if you want to remove this policy, you can use the remove retention policy and specify the hypertable. So if you run this, we get null back, which means that the policy has been removed. So basically, I suppose that's the whole process to set up data retention policies, and if you need to remove them.
Yeah, probably the two things I mentioned there. By default, when you set up that policy, I think I forget it sometimes, and I've seen others, really any policy, whether it's data retention, continuous aggregate, refresh, things like that. When you do that, it will generally run at that moment as its first run, unless you, in some cases, you can add like a, start at, next start, something like that, when you add a job specifically. So it should run fairly soon after this. So if you had chunks, it will go away, right? It's not that you're setting the policy and then it's going to wait some other time. And if you actually set that policy again, because I think you deleted it. Yeah, let's see so you can see the row count's gone, right? So it actually ran.
Yeah.
pretty instantly. So if you set that policy again and you look at the job stats, so you're not going to have much happen here, right? So go ahead and look at your job stats. And you'll see that the next scheduled start should be over to the right. Next start is on the 7th. So by default, and there's some nuances here. I think up to 24 hours, I actually forget the exact specifics, and it's something we probably should clarify in docs. But my recollection is by default, retention policies will run up to the interval, I think up to a day. So if you had like a 3-hour, you had small chunk sizes, and for some reason you had a 3-hour data retention policy, I believe it will run, in that case, every 3 hours up to a day. So if your interval is longer than a day, we basically will check once a day. So let's say you have your 3-month policy, it will run by default once a day to see if anything new has happened. So this is where you can find it, though. So I love the Attila's that you're showing this. This is where you can find kind of what that initial configuration is. And then you can use the jobs API to modify this if you needed to. And again, we have some videos on that, something we can talk about later.
Right. Now let's see what's the difference between using the delete statement and using the drop chunks function, and see if there is any like visible difference between using the two. So here in these queries, first we are going to do the same query as we did before, just to make sure, just to see how many rows we have in the table. Again, almost 10 million. Then we can do the same chunk summary to see some info about the chunks. 752 megabytes, 42 chunks. Now, let's say we want to, let me just check. I actually need to fix the table here, table name. So let's say we want to remove data that is older than 6 months. So if you were to use a delete statement for this, you would probably do something like this. Did it from stocks duplication 3, and then in the where clause, use the now function minus interval 6 months, and this will manually delete individual records from the table. So if I run this, let's see how long it runs. So it's already 4 seconds, 6 seconds. So it's already like definitely taking longer, and it's done. So it definitely took longer than just a moment. But we can, if we check the row count again, see that a little bit more than 2 million records have been deleted in more than 10 seconds. Now, what happens if we try to do a similar thing with drop chunks?
I'm just curious. Could you try something for me real quick? I don't know. Could you do the size and see what the size is?
You mean this?
Yeah, that statement there. So notice something here. Your chunks haven't gone away, right? There's still, the data might be gone from the table. You do have less data, right? So you're at 500 megabytes as opposed to 750. But the chunks aren't removed. And so you actually have overhead. You have stuff that you're logging, even though you thought you deleted this. They still exist. They still have a time range. They still have indexes, even though the indexes are generally empty or will be once vacuum runs. But you haven't actually gotten fully rid of that data, which is also just an interesting point.
Yeah, it's also interesting because the chunk, the chunk count is the same. You have the same amount of chunks, but I think the chunk, the size is less, right, because the records were deleted, but the same 42 chunks.
Yeah, and the interesting, this would have been, this took in the bottom of your right-hand corner of dbeaver, I noticed it was like 10.8 seconds, maybe almost 11 seconds.
Yeah.
And this is on a pretty small database that no one else is querying, no one else is updating, no one else is doing anything to at that moment. So if I had been, we should have thought about that. I didn't think about this. If I would have been trying to do something to that data while you were trying to delete it, it's going to take even longer. One of us has to get the exclusive lock on that table before those rows can actually finally get deleted. And yeah, so just interesting.
Now let's see what happens if we use drop chunks. So we're going to use TOX.application4 for this one. So again, just to make sure we have almost 10 million records, chunk size, chunks count. So we have all data records. Now, if we drop chunks, and again, we are using the same interval, which is 6 months. So we are dropping data that is older than 6 months. This is the same interval used with the delete function, which took more than 10 seconds. So if I run this query, already done, and we see the
186 milliseconds.
Milliseconds, yes.
Yeah.
And if you run this, we have much less rows.
So
obviously,
this is interesting. Go back up real quick. Yeah, did you notice that?
What?
So go run the same approximate row count on number 2. Yeah, so there's a couple things that you're noticing here. One, we have less chunks. The data size isn't reported correctly. And there's probably a reason for that, because honestly, the vacuum hadn't happened. And your row count, I don't know what your approximate row count on number 3 is. If you go up, where you use the delete statement right there at the bottom. So it's finally caught up to where it was. When you first did this, I was actually looking for that. You ran the delete and then you said approximate row count. It was actually still at like 7.2 million. Because in this case, this is just another example of what's happening. You're deleting data from an index, essentially a table and then the index. And so we have a function called approximate row count that's much faster because we do it based on the statistics of the table and the chunks. If you do select count from the table, Postgres doesn't have an efficient way of doing that. And it essentially really goes through the whole table to get the correct count. So because you deleted, vacuum hadn't happened, statistics weren't updated. And so you actually didn't get, it was off by almost 1 million rows, right? It actually wasn't done yet. And so you weren't even getting the correct counts. There's so many things by that simple delete statement that really don't take effect yet. So just good to know.
Yeah, a lot of nuances.
Yeah.
Right. I think that was the demo.
It's awesome.
But yeah, basically it's like I think a very big problem is with using the delete statement is that, as you said, this is a relatively small data set, but still it takes like more than 10 seconds. And now imagine if we would have like a lot of developers or people just trying to query the database, trying to get data while we are dropping all their data sets or all their data. It's just not really efficient, I guess.
It's not, yeah. Well, hopefully, I think that you've done a great job walking through each of the steps of this. So hopefully it's been really helpful for people to see the nuances that I know that you and I and the rest of the team talk about often. It's the nuances of understanding the chunks and what that means under the hypertable and how that works. So great work. No doubt that anyone seeing this in the future, the recorded version, really can work through that. Even replicate what you did. Take a table, just copy it a few different times, with a couple months and play with those things, those intervals, and you'll start to get a better idea of what's happening under the covers. So great job. So I think you have one other announcement. Is that true?
Yeah, that's actually very true. So we have a new feature in Timescale Cloud, which just recently came out, which is somewhat related to the topic of this session. And basically what this feature allows is just you can store way more data in Timescale Cloud. You can store 200 plus terabytes of data, and now you can have 12, 14, and 16 terabyte disk plans. So if I switch over to Timescale Cloud, just to quickly show you how to use it, how to set it up. So this is probably something you would see in your own Timescale Cloud service or dashboard. If you already use Timescale Cloud, you already created a service. So one change that you notice here is that now you can have not just 9 and 10 terabytes of disk size, but also 12, 14, and 16. And the very interesting thing about this is that this can allow even so only a 16 terabyte disk. Let me increase the size. So this could be the equivalent storage for an uncompressed data of 266 terabytes, which is really cool.
Yeah, I was gonna say on that previous slide, but Attila, how can you store 200 terabytes of data on only 16 terabytes of disk? And data compression, columnar compression is something we've talked about a few times. We'll certainly do another stream about it. Again, I'll put it on the screen. Please check out our docs. There's a lot of discussion around what that means, how that works, and how beneficial it can be. There's actually going to be a blog article tomorrow about this. If you're watching this later, you can go find the blog, just talking about our work getting to this stage. As part of that, this team, the developer advocate team, set up a little experiment to autoscale and see how much data we could get into one single instance of Timescale in Timescale Cloud. And so we were inserting more than 2 million rows into a table every 5 seconds. So we basically started at the year 2000, set up a script that would insert, we just randomly picked, we weren't sure how quickly it would grow. So we didn't want to go too big. So we chose 2 million rows every 5 seconds, just inserting 2 million, inserting 2 million, inserting 2 million. We're currently at more than 300 billion rows in that table. It's not a big table. It only has a couple data columns, but we're more than 300 billion rows. And currently we've only used 2.5 terabytes of disk because of compression. And so, we are talking the potential for literally more than, trillions of rows of data could be stored in a table on a single instance using 16 terabytes of disk. So really exciting. Now start to think about multi-node, putting many of these things together, and you have the real potential to store petabytes of data. It's pretty fun.
Yeah, you can have really large scale solutions. And as I know, that project that you mentioned is using Autoscale as well, which is basically, if you don't know, it lets you scale up your storage automatically. Basically, you just set a storage autoscaling limit. Let's say if you set it to maximum, which is 16 terabyte, then your database will autoscale when you are 95% of its current capacity. So really, you have large scale, and it's pretty much automated. You get emails that it happened.
Yep. Yeah, it's been fun. We have a common account for some of our projects, and every few days I log in to check email, and I get an email from Timescale Cloud saying, "Hey, we updated your storage last night," and the project, it just kept going. And like I said, we're up to somewhere north of 300 billion rows. I haven't checked it in the last day or two.
Right.
Cool.
All right. Well, I think that was it for today. Thank you for watching. As far as next steps, if you want to learn more about TimescaleDB, check out the TimescaleDB documentation. I also highly suggest joining the TimescaleDB Slack community if you're not already part of that. Slack.timescale.com. We have, I think, more than 7,000 members now who are either TimescaleDB users or they are TimescaleDB engineers. Ryan and I are also available in that Slack community. And if you want to spread the word on Twitter, you can tweet us at TimescaleDB. Or if you want to personal tweet me, I'm also available on Twitter, Attila Toth Dev. That's my handle. And yeah, that's it. Thank you very much. Thank you, Ryan, for joining.
Yeah, you're welcome. You did a great job. Thanks so much. I love getting through these topics. It helps everybody. So thank you.
Agree. Thank you, everyone. See you next week.
Take care, everyone.